Tell me, people from the last class, did you understand that you're supposed to choose u first? Did you ever understand how do you choose u at the first place? Does anyone have any intuition behind it? How do you make a choice of u? I can see from the notes you did last time, you had example when it did not work. So then, how do you choose u? Any intuition? If you don't have any intuition, it feels like it's just a pure guess. And it's exactly how I felt when I was learning it. When I was learning it, again, with no internet or help from friends, because the phone was still in the wall with the wire, I was choosing randomly for any problem, randomly, and then it would not work. So it would take like 3 pages for each problem to do integration by parts. Then I came to America and find out Lee-Atte rule. That would save me so much writing. Lee-Atte rule helps you to choose u. And it saves lots of time and frustration. So Lee-Atte helps you to choose u in order. If you see in your integral logarithmic function, choose that to be u. If you don't see logarithmic function first, but you see inverse functions, are like, let's do arcsine, right? So arcsine or cosine, choose that to be u. None of these are in the list. Okay, keep looking. Maybe you see algebraic function, then choose that to be u. For example, x squared plus 5. Some kind of algebraic function, choose that to be u. That is also not in the list, fine. You probably see trigonometric function, like sine or cosine. Then choose that to be u. So, sine x. And only the last choice should be exponential function, because it's just very annoying to choose that, and it's not really helpful to do that. It's recursive. Derivative for integral of e to the x is e to the x, so it's not really helping so much. Lee-Atte rule is an amazing hint of how to choose what should be u. From that, everything follows, because the moment you choose u, dv is fixed. Lee-Atte, such a cool idea, and I never knew that. So now I teach it. Not all books teach it, which is very upsetting. So I always teach in my classes, and that's why I have a YouTube video on that. And you definitely should take advantage of this idea. Lee-Atte, log, inverse, algebra, trig, exponential function is the last one to be chosen as u. Remember, u is the one where you do differentiation first. Let's practice, for example. Example 1. If you have integral of x to the 5 ln x dx, remember that's integration by parts, IBP. Integration by parts, is used because we need to undo product rule. Chain rule is undone by your substitution, but surprisingly it's hard to undo product rule. When you undo chain rule, one piece of the function is derivative of another piece, so there's a connection between them. Product is product of random stuff. It can be one function describing colorization of your brain seeing this room, and the other function is the work or the pressure of your eye. So when it's doing that, and then the product gives you the result. Oh, this is how the images are. Yeah? Thank you. See, finally someone reminded me. Thank you so much. So to undo product, you do integration by parts. To start integration by parts, you choose something to be u. U is chosen, dv is not chosen. So there are two functions here, x to the 5 and ln. I used to do it randomly. I was like, fine, let's choose x to the 5, work it out, works or not works, cross it off, choose ln to be u, work it out, cry, work more, and so on. You know, like, so it's frustrating. Right? This is what STEM people do. We cry a lot. I don't know. So now Lee-Atte actually tells you how to choose it. It would save me so much time when I was a student. Lee-Atte tells you to choose what in this case? ln. You see log first? Go there. So we have two functions here. ln, that is Lee-Atte L, and then algebra, that's A. Algebra showed up after log, so we choose log to be u. Boom, done. So fun. That's a very good. I'm surprised not all American instructors teaching it, because it's actually a hint from American book. So I'm choosing log to be u. u is ln x. Integration by parts involves differentiation and integration at the same time. Du is 1 over x dx. We finished half of the integration by parts set up. Now, for you to know, the moment you chose u, everything else is du. Du is not a choice. Dv, I mean. Dv is not a choice. Dv is everything is left over. You write down dv is x to the 5 dx. You integrate. V is. And that's a pretty cool idea that in the same process we differentiate and integrate at the same time. X to the 6 over 6. And we don't write plus c in integration by parts because then there's a difference happening and c minus c is 0. So we don't need that. Do you see? I will stop right now. Either tell me if you don't understand this. This is a new process you were supposed to learn on Monday. How do you feel about this? Integration by parts. This is a setup. There's a formula. The formula says uv minus integral v du. That is the formula for integration by parts. When you chose something to be u and everything else is left over called dv. So integral u dv is u times v minus integral v du. I never remember this formula. And that means that there is an easier way to learn this. So I always teach it this way. When you build the box, you don't have to create this box like that. You can rearrange information the way you like. Many students doing it differently. But if I arrange this box this way, this is how I was taught 20 years ago in Ukrainian university, and then this is the way they do it in Europe, in the United States, in Asia. Then it's actually very nice to remember. You cross multiply these two. I put equal sign in front of the integral. Integral is, as you can see, integral u dv. So it's exactly what is in the formula. Cross multiply ln x times x to the 6 over 6. Minus is in the formula. Cross multiply the bottom with the integral sign. That's how I memorize it. If you build this box visually, you can memorize it. Cross, bottom. So v shows up twice. And the second part involves integral. Integral of, repeat your v, so x to the 6 over 6, times du at the bottom over there, 1 over x, dx. Boom, done. So no need to memorize the formula. To be honest, why would you even do that if you can just visually see it? uv, and then the bottom v du is the integral. Minus part of the formula. That's why you don't do c, because c minus c gives you 0. So, interesting that integration by parts breaks down integral of the product, which was hard to integrate, into two pieces. One piece is ready. This is done. Check mark. This piece is integrated. Minus, hopefully, an easy integral. Hopefully. So that's the idea. Integration by parts takes the original one and breaks in two pieces. One piece is ready, the other one is hopefully an easy integral. If it's not easy, you do your substitution or one more time, integration by parts or anything else. Let's check. The first part is ready. ln x, x to the 6 over 6. It's a part that was integrated, you don't have to do anything about that. The second part, I will kick out 1 over 6 outside, because that's easy, smart to do. X over 6 over x is x, not x to the 6 over x is x to the 5 dx. Indeed, the second integral is easy now, so we can finish integration. Who wants to tell me what is the second integral gives you? Minus what? 1/6 integral of x to the 5 gives you what? Who wants to integrate? X to the 5? Yeah?
It's 1 over 36
x to the 6 over 6, exactly. X to the 6 to x to the 6. X to the 6 over 6 and over 6 is 36. Does that make sense? Since this indefinite integral, I'll plug plus c. Yes?
Where did you get x to the 5 on the above that?
Yeah, let me do that. I was curious if someone's gonna ask. Oops.
Wait a minute. Actually, I'm gonna. Oh,
Just a second, Chris. Wait.
never mind.
Wait.
I saw it.
This one cancel out with this one, like so. See? So 1x dx shows up from the formula, cancelled out with x to the 6, so it became x to the 5. And 1/6 I kicked it out. Now it's x to the 6 over 6 one more time, and then multiplied by 1/6 gives you 1 over 36. Agree? If you agree, put it in the box. Yeah, it's glitching today. I can feel it. Let me do this one, and I'll restart. The interesting thing is we never did such a simple example as this. Write down integral of ln x. Integral of ln x. Very interesting. So we know how to differentiate and integrate sine and cosine, arcsine even. We know how to differentiate secant squared. E to the x and a to the x. We know how to integrate that. But we never integrated log? That is interesting. To able to integrate log, you need to go in very high into material up until integration by parts. If you want to see that logarithmic function has a whole Wikipedia page. Let's do log wiki. And it's pretty cool that it has its own Wikipedia page. And it explains the graph and what it does. Lots of cool applications. Product, quotient, power, and roots, properties. And then finally it gets to differentiation. So we learn all of these derivatives. Properties we learned this in pre-calculus class. And then history, how it was derived. Sometimes I explain it in my classes if we have time. And finally, this integral shows up. And then some people remember this integral. But for you to know, this integral shows up from the integration by parts. So we're going to do it right now. Somehow, it's not straightforward how to integrate a logarithmic function. So let's do that. Example number 2. Let's find, and I'll put it in a purple color, what is finally integral of natural log of x dx. Let's do that. Very interesting.
Don't we know how to already know or we will solve that?
No, until we learn integration by parts, we don't have any way to find this integral. Use substitution will not work here. You need to figure out what to do, and then surprisingly, it's integration by parts. But integration by parts needs product.
But wait, I thought there was already an integration rule that gave you ln x. Can't Anderson do it? Or am I not thinking?
No. So you will see right now how we're gonna do it.
Oh wait, I thought that would just give you 1 over x.
Nope. 1 over x. Integral. Okay. Integral of 1 over x dx gives you log. So we know how to differentiate log, but we don't know how to integrate log. So let's learn that. But my question is integration by parts. So I will give you a spoiler that you need to use integration by parts. But then tell me, integration by parts and that's product. What is the product here? I only see one function, ln x. What do you think we should do? It's a pretty creative idea here. Where is the product?
Wait, are we going to be using the change of base formula here?
You will see in a second, Chris.
I thought you were actually asking a question.
We know. My question is, what kind of product is here? Product. Yes, if you don't have a product, made it up. What kind of product we can always make up? Multiplied by what? It's a very creative thing that 1 is everywhere, so you can always multiply by 1. Now we have a product of 2 functions, 1 and ln x. Using Li-a-te, what do you think we should choose to be u?
Well, rule says ln x.
Right? Li-a-te says you see log, don't hesitate, choose u to be log. So let's do that. If log is u, ln, yeah, it's updating, there you can see. Let's u to be ln x. Du is 1 over x dx. We did the same thing in the previous example. What is my dv then? I'll write it down like so. dv is 1 dx. Everything else is just basically dx. dv is 1 dx. Integral of 1 is what? X, thank you. And now you do integration per parts, perform integration by parts. cross product gives you equal sign ln x times x minus bottom product minus with the integral sign. So x is repeated again, x times 1 over x dx. Well, the second integral is just x over x. The first part is ready. Let me call it x ln x because it's easy to write, no parentheses needed, minus integral of 1 or 0. X over x is 1, just pointing out. Some people think it's 0. X over x is 1. Dividing means dividing. X over x is 1. So integral of 1 is x ln x minus x plus c. Some people remember this result. Usually mathematicians don't. We don't like memorizing things. So we know how to derive it. Integral of log will be x log minus x. So apparently log showed up from differentiation x ln x minus x. X ln x is product rule. You perform product rule, minus x gives you 1. There will be also 1 in the product rule. 1 minus 1 cancels out and gives you ln x. Pretty cool idea here. So that is a pretty cool idea. What do you think about that? Any questions? So simple and elegant. Let's check it while I'm restarting my needy computer. I can feel it's updating something. So write down the check and I will restart it. Somehow in this class it likes to update.